Alright, so in this video we're going to look at graphs of rational functions. We'll see how to draw some graphs, and then we'll look at how to find the stationary point of a graph without doing any calculus. Now I'm going to go through 3 examples. These 3 examples are on integral. There's a PowerPoint that goes through them as well. But the methods we're using are more or less the methods you'll use for any kind of graph that you get in Fp1, more or less. Okay, so question 1. We're going to graph y equals x over x plus 2 times x minus 3. Now, what we're doing is there are 4 steps, or you can break it down into 4 steps. Finding the intersection points, the asymptotes, well here it says vertical asymptote. I'm going to combine vertical and horizontal asymptote in one step. And step 3, examining the behavior as x tends to infinity. Essentially, we just think about what happens for very big x or very small x. And then we sketch the graph. Okay, so let's look at this. First, we start off with the intersection points. Now, when doing this, to just plug in x equals 0, plug in y equals 0. So to find the y-intercept, I plug in x equals 0. And see what I get. Okay, so that's the coordinate. So when x equals 0, of course, just looking at this, when x equals 0, plug in 0 here. It's 0 over 2 minus 3. 2 times minus 3, doesn't matter what that is. It's 0 over something, so it's 0. So x equals 0, y equals 0. So that's one intersection point over here. What about in this case, what about when y equals 0? Well, if y was equal to 0, so this whole side is equal. If that's equal to 0, well, then clearly the numerator must be equal to 0, because you can't have 0 equals a number that's not 0 over something. That's impossible. So that's also 0, 0. So that means x must be equal to 0. So this is my only one intersection point in this case. We'll see other cases where you have more than one. So that's it. That's it. Step 2. All right, so done. And step 2, find the vertical asymptotes. So I'm going to find the vertical and horizontal. Now, vertical asymptotes, so I'm just going to call them V, S, A, S, Y, M. So vertical asymptotes are when your denominator are essentially impossible values of x. So impossible values of x, or rather values of x for which I can't work out the function, are when I'm dividing by 0. So x divided by this whole thing, when my denominator is equal to 0, is where I get my asymptotes. So it's because I'm not allowed to divide by 0. So clearly, if I plug in x equals minus 2 into here, that makes this thing 0, and so it makes the whole thing 0. So x equals minus 2 is something that you're not allowed to have. So that is the equation of my asymptote, as x equals minus 2. Second, and similarly, x equals 3 is also an vertical asymptote. And we can just say, okay, if you plug in x equals 3, it makes you divide by 0. Right? So remember, these are the equations of the asymptotes, right? X equals x equals. All right. Okay, so after doing that, I'm going to draw the asymptotes on my curve, on my graph. So x equals minus 2, so let's have one here. Actually, and it should be straight, and one over here. So of course this is just a sketch, but so when doing sketches, it is important that it doesn't need to be to scale, but it is important that it's any important points are marked off. So if that crosses at minus 2, that crosses at 3. Okay, that's done. Vertical asymptote is done. I'm going to do my horizontal asymptote now. So of course, when doing these in an exam, annotate what you're doing. So just make it clear what you're working out, okay? Just to make your life easier for exam. So here I probably should have written intersection point as well. The horizontal asymptote essentially is what we think about is what happens as x tends to infinity, positive or negative. As x tends to infinity, what happens to my graph? Well, what is y? Well, y is equal to x over, and I'm going to expand my denominator. So x squared plus 2x minus 3x is minus x minus 6. Now, I'm going to divide top and bottom. In general, but you could, just by looking at this, you could probably imagine what happens as x gets infinitely big. This whole thing will go to 0, okay? But if you can't see it straight away, what you do is divide top and bottom of your numerator and your denominator by the highest power of x. So in this case, I'm going to divide top and bottom by x squared. So it's x. Now, I'm not going to write the simplified form straight away, but in future examples, I will write the simplified form straight away. So x squared over x squared minus x over x squared minus 6 over x squared. So I've divided top and bottom. I haven't changed it. I've just divided top and bottom by the same thing. Of course, this simplifies to 1 over x over 1 minus 1 over x. I'm just cancelling out. I'm simplifying it. Minus 6 over x squared. Now, let's think about this. What happens to this as x tends to infinity? Right? So as x tends to infinity, as x gets infinitely big, the numerator tends to 0, because dividing by a really, really big number makes your answer really, really small. So 1 divided by an infinitely big number is, well, it's not equal to 0, but it tends to 0. Same thing for this, same thing for this, right? 1 over x is the same reason, doesn't matter, it's minus, and then minus 6 over x squared, well, 6 over x will tend to 0 as x tends to infinity. Well, 6 over x squared, well, x squared, if x is big, really big, x squared is even bigger. So this is even smaller than anything I have here. So all three of these things here tend to 0. So what do I have? I've got this is not equal to, but this tends to 0 over 1, because 1 is unaffected by the x, but 0 over 1 is just 0. So this, don't write equals, write tends to 0. So as x tends to infinity, y tends to 0. Now, that's not my equation for my asymptote. Therefore, the equation of my asymptote is y equals 0. Right? So I'm going to sketch that on my graph now. Now, one thing about asymptotes, vertical asymptotes you can never cross. Right? Vertical asymptotes are essentially, you should think of vertical asymptotes are impossible values of x. A horizontal asymptote, rather, is not something that you can't cross. A horizontal asymptote tells you what your graph eventually goes to for very big x over here and let's say over here. Right? So that's what a horizontal. Vertical asymptotes, you never cross them. So this essentially means my graph will be split up into, well, at least, well, 3 parts. A horizontal asymptote isn't something that you can't cross, it's something that your graph goes to. All right, so that's step 1 and 2 done, and part of step 3. The next part of step 3 is think about what happens for very, very big x, positive x. So think about as x tends to positive infinity, what value do I have? So essentially what we're looking for is my graph above my axes or below my axis, or above my asymptote or below my asymptote. Right, so in this case, we can just look at the signs, or there are 2 ways of doing it. You can either look at the signs or just plug in a value. So I'll talk about the signs thing, but the signs thing isn't really applicable. Well, it is kind of applicable, but in other situations, if it wasn't 0, you can't use sign. You'll have to look at if it's, for example, if my asymptote was, in my next example, I think we have an asymptote of y equals -2. Then you're not looking for is it positive or negative, you're looking for is it bigger than -2 or smaller than -2. In that case, it's harder to do what I'm about to do right now. So in this situation, what you're meant to do, what you should do, is just plug in a number. That's what I'm going to do. So let's plug in x equals when x equals, let's say 100. What is y? Well, y is equal to 100 over 102 times 97, right? So, and this, it doesn't matter what the value is, but, well, it is bigger than 0. That's what we really care about, because we're relating it to my asymptote. We're relating it to my asymptote. So you could just use a calculator and work it out if you want to, if you're not sure what that is, but clearly that's a positive number. It's 100 divided by 102 times 97. And that's 0.00. I'm not even going to write it. I'm just going to say it's greater than 0. Now, the fact that it's greater than 0 means as x tends to positive infinity, over here on my graph, this is what's going to happen. Oops, apologies. Let's say this happens, right? What about as x tends to negative infinity? By the way, we could have seen this by just thinking about looking at my original graph and thinking about, well, if I have really, really big x, what's my sign? If I have really, really big x, that's positive, that's positive, that's positive. It's positive over positive, so it's positive, so it's greater than 0. What about as x tends to negative infinity? Again, we can just plug in a big negative number. So let's say x equals -100. So that gives you y equals -100 over, right? So it's a -100 plus 2, which is -98 times -100 minus 3, so -103. Now clearly this is negative, right? Wait, is it negative? Yes, it is, because this negative times negative is positive, and a negative divided by a positive is negative. So this is less than 0. So what does that mean? That means on my graph, and that means on my graph, for x really, as x tends to infinity, in fact, I should have written here as x tends to, well, as x tends to infinity, well, I can write here, and I'm running out of space really. I'm going to rub out some of these things. Y tends to 0, because this will number, if you plug into kind of put bigger and bigger numbers, you'll get closer and closer to 0. And so we also know it should tend to 0 anyway, because that's my horizontal asymptote. Y tends to 0 from below. That's why we're going to write 0 minus, because this is less than 0. So this is what we have here on our graph. Similarly, and I didn't write it before, so I'm going to rub this stuff out because just to give myself a little bit more space. Because of this, as x tends, for very, very big x, y tends to 0, yes, because and you see it if you plug it into a calculator, and we already know it tends to 0 because it's a horizontal asymptote, but it tends to 0 from above because it's greater than 0. So I'm going to get rid of this now. This working out doesn't really matter. These are the important bits. So y tends to 0, yes, we already know that, but it tends to 0 from above. Okay, so these two things combined because of this bit gives me this bit gives me this bit. Okay, so that's step 3 done. Step 4 is complete the sketch. Okay, so we can't, if I'm going to get rid of, actually I'm not going to get rid of this stuff. So now there's, just looking at these things, okay, so you can't cross the vertical asymptotes. And what happens at a vertical asymptote is really your denominator is getting smaller, because as I get closer to -2, this thing here gets closer and closer to 0. So I'm doing something divided by a really, really small number. So it's either going to get really, really big negatively or really small. It doesn't matter. It's going to either going to go like this or it's going to go like this. It's going to go up really, really big positively. Now, there's only one, in this situation, there's only one thing that can happen, right? You can't, this can't happen in this question. This can't happen because this will give me another intersection point. But we've already found all the intersection points. There's only one intersection point. So that can't happen. So we know exactly what's going to happen here, right? So it's going to be like this. Now, be careful when you do your sketches. That I'm going to rub this bit out here for now. When doing your sketches, do not give it a turning point if it's not meant to have a turning point, okay? So be careful about that. Now, what about over here? Well, for exactly the same reason. There's only two things that can happen. It's either going to go up or it's going to go down here, right? Because as x tends to 3, this thing tends to 0, so it's something divided by something that's really, really small, something that's close to 0. So it tends to infinity, either positive infinity or negative infinity. But it can't be negative infinity, because if it went to negative infinity, because I know it's positive here, it has to cross the axis again, and we know that can't happen, right? So it has to be like this. Okay, so now we've got what's happening in the inside, right? There are actually 4 possibilities here. That's a point of intersection. Now, the easy one you might see is this one, right? I'll do it green. And the ones you might see straight away, and I'll do another one in red, and this one, right? So it's like an x cube curve. My graphs, I'm drawing on a graphics tablet, so my graphs, but those aren't the only 2 possibilities. There are actually 2 more possibilities. The other ones are this, essentially, like an x squared, or the upside down version of that. So we've got 4 possibilities, and we need to narrow it down, right? So which one is happening? So to do that, what we do, now we can, like we did before, we could just analyze the signs. Okay, so by the way, this one, I didn't say it, but for a very negative number, I could have got this just by saying, okay, for really, really big negative numbers, x tends to negative infinity, that's negative, that's negative, that's negative. So it's negative divided by negative times negative, which is positive. Negative divided by positive is negative. Again, we don't need to do that. We can just plug in a number. So what I'm going to do now is to figure out what happens over here. I'm going to plug in a number that's between -2 and 0, and then I'm going to plug in a number between 0 and 3. Well, let's do 0 and 3 first. Right, 0 and 3, an easy number to plug in between 0 and 3 is 1. So when x equals 1, let's just find the coordinate. Well, when x equals 1, y equals, well, 1 over 2 times, sorry, when x equals 1, so that's 1, that's 3, that's 1 minus 3, which is -2. So it's 3 times -2. So it's minus 1 over 6. So when x equals 1, which is over here, I've got a negative coordinate. So it's something over there, minus 1 over 6. So that already narrowed it down by half. I know that I've only got 2 possibilities now. Either, so look at my pen on the graph, either this or this. Now, how do I figure out which one it is? Well, I plug in a value in between 0 and -2. Well, what's a nice value to plug in between 0 and -2? Well, I'd say -1 is a nice value. So let's plug in x equals -1 and see what happens. Well, x equals -1, y equals -1 over -1 plus 2, which is 1, and -1 minus 3, so -1 plus 2, which is 1, and -1, I'm looking over here, -1 minus 3 is -4. So it's -1 over, this whole thing gives you -4, so it's -1 over, it's 1 over 4, so that's positive. So that's up here. Now, it doesn't matter exactly where, we're just doing a sketch, so 1 over 4. Now we're done, right? We just need to finish ourselves. We know it's positive over here, it's negative over here, so there's only one way graph. It has to go through my intersection point there. So there's only one way it can happen, one graph I can have is that. Now I'm going to get rid of these because I don't want to have to go through these points, right? I mean, I did that for illustrative purposes, but so my graph will look something like this, okay? Right, so of course when drawing your own one, it should be a little bit nicer now. And that's it, that's the whole process, right? We've got 2 more examples, let's look at those. All right, so we're drawing the graph of y equals 4 minus 2x over 2 plus x. Again, let's start off with my intersection point, intercepts. So I'm just going to write, actually, I didn't write before, so let's say right, intercepts. So for my y-intercept, of course, that's when x equals 0. So just plug in x equals 0 as a coordinate. I'm going to start writing off coordinates straight away anyway. So when x equals 0, what is y? Well, y is equal to 4 over 2, isn't it? Because the x part is minus 2 times 0, 0, and plus 0, 0. So that's just 2. So that's one intersection point. To my other intersection point, I plug in x equals 0. So maybe if you want to try working out, so you can say when x equals 0, y equals 4 over 2, so that gives you this coordinate. When, I'm going to rub this out though, when y, next thing to find my x intersection is when y equals 0. When y equals 0, I've got 0 is equal to 4 minus 2x over 2 plus x. Right, now the denominator doesn't matter, because if 0 is equal to a fraction, the numerator must be equal to 0. So 0 equals to 4 minus 2x, and that gives me x is equal to, well, the 2 minus 2x goes over to the other side, so 4 equals, or add 2x to both sides, 4 equals 2x, so x is equal to 4, x is equal to 2 divided by, wait, it's x is equal to 4 divided by 2, which is 2, right? So that's my coordinate. Again, if you're not sure, just plug, or if you want to check, just plug in a value, because you don't want to make mistakes here. So let's plug in a value here. So if x equals to, what do I get? So it's 4 minus 2 times 2, which is 0. So y equals 0. So we're done. Okay. All right. So those are my intersection points. I've got 2 intersection points this time. I'm going to get rid of that. So on my axes, now I didn't actually draw my, let's just bring my axes over. And just gonna, I should have done this earlier. Apologies. So get rid of that, and let's just take this all with us. I need to group it, don't I? I need to group it and then copy. Wait, what's going on? I just press Control C, and apologies, and put one on the next page as well. All right, so I know my intersection points. So I've got 0 and 2 and 2 zeros. So let's just plot them. So when x equals 0, y equals 2. So let's put one up there, and actually maybe do a cross and label the point, of course, 2. And when y equals 0, x is equal to 2 to 2, 0. So let's put it here. All right, so we've done my intersection points. Next thing, asymptotes. Easy one to do first. Easy one to do is vertical asymptote. All right, so in fact, you could probably just write the whole word. I didn't really save much time. Okay, so vertical asymptotes. Well, that vertical asymptote is when your denominator is equal to 0. So it's when 2 plus x is equal to 0. That gives you x equals minus 2. And there's only one vertical asymptote here. So that's your vertical asymptote. That's the equation of your vertical asymptote. It's when your denominator is equal to 0. Right? So x equals minus 2. Let's do a line for that. And then we're going to find our horizontal. So x equals minus 2. So let's say it's over, we'll do this one in blue, let's say. And that's over right here. So it should be roughly symmetrical to the other one. All right, so that's x equals minus 2. Let's do my horizontal asymptote now. Oops. So horizontal asymptote, if just current, you should actually, and I didn't say this earlier, but you should try doing this. And try doing this on your own, right? So you should be able to do it. Try doing this on your own, and then just check that you get the same things. If you haven't got it, I mean, of course, you can still look. So that's my vertical asymptote. Let's put it next to the vertical asymptote. Horizontal asymptote, of course, we're just thinking of as x tends to infinity. What does y tend to? Well, y is equal to 4 minus 2x over 2 plus x. Now, what did I say we're going to do? We're going to divide top and bottom by x. Oh, divide top and bottom by highest power of x, so in my denominator. Remember, it's always we always check with the denominator. Okay, so highest power of x in my denominator is x to the power 1. So I'm going to divide top and bottom by x to the power 1. So it's just going to become 4 over x. I'm going to do the simplified version now. Minus 2 over x divided by x is just minus 2. 2 over x, and x divided by x is just plus 1. Now, clearly, looking at this, as x tends to infinity, what does y go to? So as x tends to infinity, y tends to, well, this, as x gets infinitely big, 4 over x tends to 0, 2 over x tends to 0, so this whole thing tends to, well, that's 0, so the whole thing tends to minus 2 over 1, which is just minus 2. So that gives me my equation of my horizontal asymptote. So remember, if they, in an exam question, when they ask you for the equation of the asymptote, or when they ask you just for the asymptotes, don't say y tends to minus 2, write y equals minus 2. Okay? All right. So let's do a line for that. And let's carry on do blue, and it should be roughly about there. All right. Now, in this case, actually, I more or less already know what the graph looks like. More or less, right? You could probably much, because just look at this. What can happen? Is it possible that I'm going to get something like a horizontal asymptote is something you're definitely going to approach, right? So it's not going to be that, because if it's that means I cross the axes, right? So on this side, it's going to be like this, and on this side, it's going to be like this. It's something you can actually take shortcuts now, and you can see there's only one possible answer. I will finish it off now just for practice. All right, so I've done that. I've done step 2 and part of step 3. I found a horizontal asymptote. Now I need to find my behavior as I approach the asymptote. For all we know, yes, we know it approaches them, but it might do this. For example, it might go below it and then go above like that. I mean, it's not going to cross my vertical asymptote, but it might cross my horizontal asymptote. We don't know why. And actually, we're not going to know from this question, really, because we don't know if there's a turning point or not. So what we're going to do will tell us if it approaches from above or below, but it's not going to tell us if it crosses it. Don't worry about that. You're not going to lose any unless they ask you to find a turning point. They're not expect you to be that accurate with your graph. So as x tends to infinity, so as x tends to positive infinity, what does y tend to? Well, what we're going to do, like before, we're just going to plug in a big value. So this is one where we don't want to see x is really big. We can't check the signs, because what we're really looking for is y bigger than my asymptote. So as x tends to positive infinity, am I bigger than my horizontal asymptote, which I should have labeled -2, or am I smaller than my horizontal asymptote? So am I approaching it from above or below? So the way we do this, we just plug in a number. So let's just plug in when x equals 100. What do we get for y? Well, y is equal to 4 minus 2x, so 4 minus 200 over 2 plus x, so it's 2 plus 100. So 4 minus 200, okay, so what is that? So 4 minus, let's just write it as a number. So 4 minus 200 is minus 196 over 2 plus 100 is 102. Well, this is negative, right? Now, this is negative, but what we really care about is it negative or positive? Because we knew it's going to be negative, because we knew it's going to be over here. We want to know, is it bigger or smaller than my horizontal asymptote? So is it bigger than -2 or smaller than -2? Right? Now, if you're not sure about this, if you're not sure how to say if this is, well, you should, just by looking at this, just think about this. If I did a -200 over 100, right, that will be -2. If I make my numerator smaller, I'm getting a smaller negative number. So essentially, I'm above -2, right? So like minus. And then if I make my denominator bigger, I'm also. So I know just by looking at what this is, this is greater than -2. But of course, if you're not sure, if you don't see that, just plug it into your calculator. So minus 196 divided by 102 is that, and you use a decimal. Notice it's bigger than -2, right? So that's that. So what we can write as x tends to positive infinity, y tends to -2 from above, right? Because bigger than -2. Okay, we're going to do exactly the same thing, and you can try it yourself for when as x tends to negative infinity, because we don't know what happens over here. Right? I'm pretty sure this is what's going to happen, but let's just check. As x tends to infinity, negative infinity, let's plug in y, x equals negative 100. So y is equal to, let's say x equals minus 100. Y, also make sure you write down what you're doing, right? Because don't just go straight into it. Make sure the examiner could follow what you're doing can be followed, and it makes sense, and the working out is there, and it's logically laid out. Now it won't be like I'm doing everything on a single page, so and there are lines, but what you're doing should be neater. So when y equals minus 100, well, it's 4 minus 2 times minus 100, so it's 4 plus 200 over 2 minus 100. Okay, so it's 4 plus 200, because it's minus 2 times minus 100 is plus 200. So what is this? So it's 204 over minus 98. Now I know just by looking at this that this is smaller than minus 2, because, well, this is a negative number, and forget when I say smaller and bigger, I just mean it's less than minus, like minus 2 point something, because this is bigger than 200, and this is smaller than that. If you don't see it, just plug it in. Okay, so just plug in 204 divided by minus 98, and you see it'll be minus 2 point something. All right, there we go. That means it approaches as x tends to negative infinity, y tends to minus 2. Of course, we knew that happens. We know that happens. Sorry, because that's my horizontal asymptote, but it tends to it from below because it's less than minus 2. So this happens here. Okay, so that's step 3 done. Step 4 is complete the sketch. Well, as I said, we're done, right? So there's only one thing that can happen. So the tricky bit here for me now is actually sketching it. So this happens over here. Make sure you don't cross your horizontal asymptote, or your vertical asymptote. That's very important. Over here, this happens. All right, so I didn't make it line up with that. So if you didn't, maybe I could just rub that a bit out. Yeah. And over here, there's only one thing that can happen. Is this, right? And we already know that because we know it has to be that. It can't go up because if it went up, they have to cross my axes, and we know there are only two intersection points. It can't cross here. That's my graph. So really, what this should have looked like if I was doing it, would be like this. Really, oops. So I can't. I'm finding it difficult to like that kind of more or less. Right? If you drew it nice and neatly, right? So make sure this doesn't cross your asymptote here, so it's nice smooth curves. Right? I'm finding that difficult too because if you don't know, while I'm not writing at what I'm looking. Well, sorry. I'm writing on a tablet, but I'm looking at a screen, so that's why it's a little bit off. And I haven't done a video for a while, so my handwriting's gone a little bit off as well. Anyway, that's it. That's done. Third example. Right, I'm going to do this one a little bit quicker. Well, hopefully, because these have been kind of slow. All right, so first up, intersection points. So intercepts. So let's plug in x equals 0. When we plug in x equals 0, what do we get? Well, we get my numerator. Well, let's just look at it. I'm just going to plug in 0. That's 0 plus 0, so it's 4 over 0 squared plus 3, so it's just 3. So when x equals 0, y equals 3. So our coordinate is 0, 4 over 3. So we can even put that on our axes already. So 0 and 4 over 3. Let's just say it's here. Of course, remember, label it 4 over 3. And when y equals 0, oops, sorry, that's in the wrong place, isn't it? When x equals 0, y equals 4 over 3. Be careful about that. So 4 over 3 here. And my second intersection, y equals 0. When y equals 0, well, I've got 0 is equal to... Sorry, my mic is shaking a bit. Okay, so when we've got 0 is equal to x squared plus x plus 4 over, so that's my thing, x squared plus 3. But of course, if this 0 is equal to this, then my numerator must be equal to 0. You can just see, I can multiply both sides by x plus squared plus 3. Or ignore that. If you've got a fraction equal to 0, the numerator must be equal to 0. Now we just need to complete factorize and solve this quadratic. Well, if it factorizes, factors of 4 are 1 and 4 and 2 and 2. Neither of them add up to give me x. So when solving this, either complete the square or use difference of two squares. I will complete the square. It's not difference of two squares, apologies. To complete the square, I'll use the formula. I'll complete the square. So it's x plus half squared minus a quarter plus 4 equals 0. So x plus, of course, you can just use your quadratic equals, so that gives me 3 and 3/4, or 3.75. Again, it's better to use fractions. Or what did I say? I said 4 minus a quarter is, well, this is 16, actually 16 over 4 minus 1 over 4, so 15 over 4. So it becomes positive here, so it becomes negative. So negative 15 over 4. All right, so now we've got a problem, right? Do you see it? We're not doing complex numbers here. I can't do anything anymore. If I square root both sides, well, I can't square root to negative 15 over 4. Well, we can do it with complex numbers, but this is not a complex number question. Right? These are real x, real y. I'm not going to draw a complex root here. This is not a complex plane. So that means there are no roots. That means this is not possible. Of course, if you use the quadratic formula, you could have got to that as well. Or you could just use you could have used the discriminant, b squared minus 4ac. You'll see here it will be less than 0. So y is never equal to 0. So there's no intersection point, right? So it doesn't work. So my only intercept is 0, 4 over 3. Okay, so that's step 1 done. Let's go into step 2. Find the vertical asymptotes. My vertical asymptote is when my denominator is equal to 0, right? So let's say v. Well, that means when x squared plus 3 is equal to 0. Well, can x squared plus 3 ever be equal to 0? Well, no, because x squared, the smallest x squared ever is 0. So the smallest x squared plus 3 ever is 3. Of course, you could have just said that, okay, that means x squared equals minus 3, and then you can't solve this. Again, we're not allowed to do complex numbers. We're here. So there is no vertical asymptote, right? No vertical asymptote. Done. Horizontal asymptote. So now just think about as, so as x tends to infinity. Let's do positive and negative in one go. Okay, so we've got y is equal to x squared plus x plus 4 over x squared plus 3. Now, what did I say? You divide top and bottom by the highest power of x in your denominator. So I'm going to divide top and bottom by x squared. So actually, I could just write it here. I haven't done that before. So x squared, x squared, x squared, x squared, x squared, and then think about what happens as x tends to infinity. The reason why we do this is because when we divide by something, and then when you have those fractions, and you saw, then it's easy to do it. Easy to do. Think about as x tends to infinity because loads of things will tend to 0. So that's equal to 1. So it's just equal to, because I'm plus 1 over x plus 4 over x squared plus 1 over 1 x squared over x squared plus 3 over x squared. Now clearly, as x tends to infinity, that tends to 0, that tends to 0, that tends to 0, okay? So 1 over x tends to 0, 4 over x squared tends to 0, 3 over x squared tends to 0. As x gets infinitely big or infinitely small, these all things go to 0. So it's just 1 over 1. So y tend to 1. So what's the equation of my horizontal asymptote is y equals 1. So my horizontal asymptote, this is not my horizontal asymptote. This is how I worked it out. My horizontal asymptote is y equals 1, right? So we draw a horizontal line there, right? Now, of course, when you're doing these, do dotted. Try to do dotted. Don't do solid. I mean, you can do solid, but a solid line may be misinterpreted to be part of the graph. Okay, I mean, it shouldn't be, because it should be obvious from context. But again, if that's 4 over 3, so this is going to be below my axis. So that's 1 and 1/3. So I'll put it here roughly. Again, it's just a sketch. Because when doing a sketch, it is important you mention, or you just write that's 1. Just make it explicit that you know what you're doing. Right, and then you've got the right point. All right, so we've got that. Now we need to think about what happens as x gets really big and gets really small compared to this asymptote. We're going to plug in positive value, big positive values, big negative values. So as x tends to positive infinity, so now we're just thinking of the positive infinity. By the way, actually, you could have skipped what I did before, because you would have got the same answer. So if what I've done here, so all the x squared over here, you can actually skip all of those, because just by plugging in really big values, really negative values, you will find your horizontal asymptote. So that thing where I just did, where divide top and bottom and all that stuff, you don't really need to do that. You can just plug in really big values to find your asymptote. Well, kind of, because you don't really know. You should do what I did before, because just because you find a quadrant doesn't mean that's what an asymptote is. By tending to infinity, that's what we know as asymptote, or that's how we find asymptote. Okay, let's just find the behavior. So we're going to say x, just plug in x equals 100. So what do we have? All right, I'm just going to just look at this. We're concerned about, is it above 1 or below 1? Well, y is equal to, well, 100 squared plus 100 plus 4 over 100 squared plus 3. All right, I'm just going to work it out. So 100 squared is what? 10,000 plus 100 plus 4, so it's 10,000. 104, 10,104. What's my denominator? Am I right? It's 100 squared is 10,000? Yeah, 1s and 4 zeros. All right, so it's 100 squared plus 3, so it's 10,003. Now, is this bigger or smaller than 1? Well, I think it's bigger than 1, but if you're not sure, right, just plug it into your calculator. So 10,104 divided by 10,003, and that is bigger than 1. And that's what we care about. Is it bigger or smaller than my horizontal asymptote? So as x tends to positive infinity, y tends to 1. Of course, we already know that. But it tends to 1 from above because it's bigger than 1. So it's over here. That's what it'll look like. All right, now we're going to do exactly the same thing. We're going to plug in minus 100. All right, so let's just get rid of, no, we don't need to get rid of all of that. So I'll get rid of this bit. Well, you know what? I'm just going to adjust this. So I'm just going to write underneath. No, I can't. I need to change too many of these numbers. So as x tends to negative infinity, what does y tend to? Well, I'm pretty sure it's going to be 10 to 1 from above, but less, because it can't do this. Well, actually, I mean, it could. For all we know, it could. This could happen, and then it goes up again. All right. So, but there are possibilities here. But let's just look at it. What do we do? Well, let's plug in x equals minus 100. What do we get? Well, y will be equal to minus 100 squared, so it's just still positive. So 10,000. So it's going to be 10,000 minus 100 plus 4. 10,000 minus 100 is 9,900. 9,904. So my top, I have 9,904. In my denominator, I've got 10,000, because minus 100 squared is still 10,000. 10,000 plus 3, which is 10,003. So let me just double check that. When x equals minus 100, so 10,000 minus 100, which is 9,900 plus 4, 9,904, 10,003. Okay, now this is going to be smaller than 1. So in fact, I was wrong. So it's always worth checking these. So let's just, and if we're not, so 9,904 divided by 10,003 is smaller than 1, right? So this is smaller than 1. So this, as x tends to negative infinity, y tends to 1, yes, but from below. All right. Okay, now we know this happens. So now let's complete our graph. So what are we going to do? We're going to use my asymptote, and we're going to use the intersection point. So I'm going to get rid of that thing there because it's going to get in the way a little bit. So I'm going to get rid of that. But you should have it on your graph. I'm just going to get rid of it because it's going to get in my way. So what happens in my graph? Well, clearly it has to go there like this, like that, and then like this, and then at some point you'll have to turn because it can't. So let's just, right, so okay, it shouldn't be like a straight line. It should be more of a sketch. So of course here what I've already drawn is a bit of a problem. You can use your rubber, so just think of like this, and of course I've missed my intersection point, which is a problem. Now this can't happen, right? Because we know it approaches it from below, so it must at some point go below that line. So what really you should have is, all right, so this is, I'm going to get rid of this intersection point because I'm just going to draw my intersection point in afterwards, right? So this is what's going to happen. Okay, something like that. Where that, now we don't know where our turning points are, so that's 4/3. That's my intersection point, that's 4/3. And that's my asymptote. Okay, so something like this happens. Well, how do I know it's something like this and not like what I had before, so like that? Well, let's say I'm making a mistake, so I'm going to just double check my answers because I may have made a mistake here. I'll was quick. Oh, sorry, no, I'm right about this. Oh wait, no, yeah, we're right about this. Okay. Now we don't know where the turning point here is. We haven't found the stationary point because the graph, now I put a turning point, there's a turning point obviously somewhere here and there's a turning point here. Now we don't know if it turns here or here or here. We don't know exactly. We haven't found the stationary point. So this is my sketch going to be roughly. This is not going to be exactly what the sketch is because I don't know where my turning points are exactly, because for all we know, it might turn, this turning point or stationary point might be over here, or it might be over here. This one, well, it's going to be on this side somewhere, or it might be over here. For all we know, it might have been something like this. My graph could have been, well, it has to cross my axis at 4/3, I know that. But it could have been like this, where that's 4/3, right? Or it could have been something, it could have been like this. Roughly, they're still the same, but for all we know, it could have, no, it could have, what I'm saying is it could have carried on going up here and then turned really late. We don't know. So that's what leads us into the next question. All right, next section. So this is more or less done. From all the information we have, we can't do anything more. Finally, how do we find where those turning points are? So how do we know if my graph is either that, or maybe it was, I'm not going to rub it. So maybe, for all we know, it could have been like this. It could have been like this. All right? Or, okay, this should approach this. This shouldn't be so sharp. Or it could have been like this. Right, how do we know about all these things? Well, that's why we need to find what that turning point is, that stationary point. Again, ignore my things, they're really rough here. All right, so we're going to find stationary points without doing the calculus. Now, this was the answer to that previous one. This was what the actual graph looks like for that example we've just done. So what we're going to do is going to see how we find these points, okay? A turning point or a stationary point. Now, you are not allowed to do calculus from C1, right? You can't do differentiation to find those, right? You can't use dy dx. What we're going to do instead is, I've done this in lesson, essentially we're going to make our graph equal to, so this is the equation graph, I'm going to make it equal to k. So we're going to solve, so I'm going to put k there, okay, green is probably hard to see. I'm going to explain this actually. I know usually I don't explain everything. In this particular case, I will actually explain the theory a little bit. So we make it equal to k. So that's essentially thinking about when my graph is equal to a horizontal, or straight horizontal line. Right, so I'm looking for the intersection point. So let's do some straight horizontal lines of So these are my for different values of k, right? So this is my left-hand side. That's that, right? And this is my curve. Well, how do I find my turning point? Well, if you think about this, right? Think about all these lines. Well, this for this value of k and that curve, my graph has this will have no solutions. So if you make the quadratic, you will have your discriminant b squared minus 4ac will be negative. For here, where my two intersection points, this graph for this value of k, for whatever value of k I put here, this whole equation, there are two intersection points. So this whole thing will have two solutions. That means when you make the quadratic, b squared minus 4ac will have to be greater than 0, right? Just to link back to, if you don't know about discriminant, this is a bit in C1 or C2. I'm not going to talk about too much now. Now, what about there? Or actually, this one probably should be a little bit higher. So for this line, so this is the line y equals k. By the way, these are all different for different values of k. For this value of k, there is only one intersection point from my line y equals k and my curve. That means because there's only one intersection point, and more than that, not only is there one intersection point, it's a repeat. You can just look at it, it's a repeated root. When I make my quadratic equation, of course, I need to rearrange it. My b squared minus 4ac will be equal to 0. That's how you find turning points. So just in general, to find your turning points, you make it equal to k, you rearrange to make your quadratic, and then when you work out find b squared minus 4ac, for what value of k b squared minus 4ac is equal to 0, right? So of course, I will show you that in the next example. To find where it's, and if in a question where they say find the range of your graph, right? That means the horizontal. You find where b squared minus 4ac is greater or equal to 0, and that'll give you a range. So that'll tell me where my graph goes in, what my graph goes in between. In fact, I could actually just do this in one go, and this will both give me my range and where my turning point is. If you want to find where your graph is invalid, well, that's when you're looking for when b squared minus 4ac is less than 0. Of course, in each of these situations, I'm starting off from this, I'm multiplying it out, making the quadratic, and then doing b squared minus 4ac. So let's look at the next example. Let's look at an example. So example 1, we want to find the coordinates of the turning points of y equals x squared plus x plus 4 over x squared plus 3, and then we want to sketch the graph. So let's do the turning points first. To do this, we make it equal to k. So k is equal to x squared plus x plus 4. You don't need to use k, by the way. You can use any letter if you want to. Well, I would avoid using a, b, or c because we're going to use those in a discriminant. I would also avoid using letters like x and y because those are usually variables. K is what we're going to use. You could use others if you wanted to. Now, we're going to make this into a quadratic. This is not a quadratic equation. This is a rational function. It's not a quadratic equation. So we need to bring it over and make it just something like something x squared plus something x plus c, ax squared plus bx plus c. So this rearranges to clearly kx squared plus 3k equals x squared plus x plus 4 is equal to 0. Oops, not equal to 0. All right. So I just multiplied both sides by x squared plus 3, so it disappears from here, goes up here, and just multiplied out the brackets as well. Now I'm going to take everything over to the same side and gather my like terms. All right, so it's going to be x squared minus kx squared. Now I will factorize it next, although you can do it in one go. Plus x, that's a 3, plus 4 plus 3k equals 0. Notice I've grouped these, my x squared together, my terms in x, and there's only one term in x, and my other bits together. Right? So these are my constant terms. Notice 3k doesn't have an x, so I'm going to group it with a 4. So now let's think about what's my a, b, and c. Well, in fact, I'm going to write this instead as x squared, and on the inside 1 minus k plus x plus, I'll write in brackets 4 plus 3k. You don't need to put this bracket around the 4 plus 3k, but clearly now the reason why I've done this, and this is your a in quadratic equation, ax squared plus bx plus c. This is your a, this is your b, well your b here is this invisible one, and this is your c. So now let's use my discriminant, b squared minus 4ac. Now, we want to find the turning point, so we make it equal to 0, and then we find what? So that means x squared, b is 1, remember? Not x squared, sorry, b is 1. Okay, if you're not sure, just write equals, so b is 1. So it's 1 squared minus 4 lots of a is 1 minus k, and c is 4 plus 3k. And we're solving for when this is equal to 0. Okay? All right, so hopefully I haven't made any mistakes with my algebra yet. I mean, it's very possible I do make lots of mistakes, as you've probably noticed by watching these videos. Just realized I made a mistake. course, that should have been 3 there. And you didn't notice it because I've actually edited a lot out. I haven't made it. I spent a while going down the wrong route. So that should have been -3. I made a big mistake there. So be careful about this. It would have cost me. There's a -3, is a -3, is a -3. And then this thing, you expand it and you solve it. I will put the working out here. So that gives you 1 minus 12. So if you expand this, it was 1 minus 12k squared plus 28k minus 16 equals 0. And this gives you 12k squared minus 28k plus 15 equals 0. And this factorizes to 6k minus 5, 2k minus 3 equals 0. And this gives me two values of k. This gives me k is equal to 5 over 6, or k is equal to 3 over 2. All right, so what we've done here, so just to recap briefly, so what we've done is we made it equal to k, right? Multiplied it out, right? Brought everything to the same side. Found my a, b, and c to find my discriminant. Made my discriminant equal to 0. Right, here's my discriminant, b squared minus 4ac, plug in my values. Multiply it out, solve your quadratic. You've got your two values of k. Now, what are these two values of k? Well, these are where my turning points are. Right? Now, essentially, for values of k, just think about what you're doing here. This is, if you go back to what I was doing here, this is your value of k. These are my lines, y equals k. So you found that where this happens and this happens. So this, you found, so we know that my turning point, one of my turning point was at 5 over 6 and the other one was 3 over 2. Those are your y values. Those are essentially your y values. So you need to find the respective x values for those y values. Okay, so once you found your values of k, those are, just think about, those are your y values. So I'm not going to rub those out. So this video has been quite long. I'm going to try to speed up a little bit. Apologies. Okay, so for those values of k, you need to find your y. So how do you do this? You need to find your x. So these are your y values. So when y is equal to 5 over 6, you need to find your value of x. So you plug it in here. So this is quite long-winded. It's quite a decent amount of work. So we're going to have 5 over 6 is equal to x squared plus x plus 4 over x squared plus 3. Now, how do you solve this? Well, I'm going to do one of these. I'm not going to do it for 3 over 2. If I do one of these, hopefully you can see that should be a 4. It's a messy 4, but that's a 4. So what we're doing is just multiply out, and then you got it, and you're done. So, for example, this will give me the equation 5 lots of x squared plus 3 is equal to 6 lots of x squared plus x plus 4. Multiply it out, make it equal to 0. So 5x squared plus 15. On the other side, I've got 6x squared plus 6x plus 24. Make it equal to 0, so it gives me, subtract this from this side, so I've got x squared, and then 6x plus 6x, and then 24 take away 15, which is 9 plus 9 is equal to 0, and then this gives me x plus 3, so my turning point is, so x is equal to -3, so I know one of my turning points. So for an x equals 5 over 6, when y equals 5 over 6, x equals -3, so one of my turning points is -3, 5 over 6. You do exactly the same thing, make it equal to 3 over 2. So just make it, instead of here, write 3 over 2, solve that. Again, it's not going to be too much work. I'm not going to do this. Hopefully you've got it by now. If you're not sure, you can look at the integral notes. So when y equals 3 over 2, now I'm just going to look at my notes. Oh, I'm going to look at the integral notes, really. When y equals 3 over 2, just plug it in here, 3 over 2, solve your quadratic, or multiply both sides, and you should get 1. So that's my other turning point. 1, 3 over 2. Now let's sketch this curve. Now I think, what was it? Is this the same one we did before? Yeah, x squared plus x plus 4 over x squared plus 3. Yeah, it's the same one. It's exactly the same one. So now we know our turning points. So let's just remind ourselves what the graph was like. It was something like this. We had a horizontal, and let me just actually, you know what? I'll just copy this whole thing. So let's group it and then copy. All right, so this was our graph. Now let's get rid of what I drew before. So, but we're going to keep our asymptote. Asymptote was at 1. My intersection point was at 4/3. So asymptote is at, this is y, 1 intersection point. Let's put it high actually, so make our life a little bit easier. 4/3. What are my turning points? Well, I've got one turning point at -3 and 5/6. So -3, let's say -3 there, 5/6 as a coordinate. So remember that's 1. So -3, 5/6 is less than 1. So something over here. Again, that as a coordinate is -3, 5/6. What's my other coordinate? It's 1 and 3/2. Now 3/2, how does 3/2 compare to 4/3? Well, 3/2 is bigger than 4/3, so let's say it's up here. In fact, it should be, if that's -3, it should be closer. So you should say it's, actually I made a mess of this. So let's make the -3 over here. So -3. So there, so that's my coordinate, -3, 5/6. And my coordinate 1, 3/2. So let's say it's up here. That's 1. So that's 1, 3/2. So it's above this. So what does my graph look like? Well, I know it. Well, to draw this, I know it approaches here from below and it turns here. It has to go through that intersection point. So actually, that should really be a turning point. So what I should do is just do it. From here it turns, and there it turns. Be careful that you don't do any more turning points. That turns there and gives us that. So that is that graph there. All right. Now, as an aside, what about if they ask us for, instead of this, so this is final bit. Imagine they didn't ask for you the coordinates of the turning points. Imagine they asked you instead. They gave you that graph, and they said find the range. How do we do this? Well, looking at my graph, essentially what range means is what are my y values. And we know just by looking at this what the answer is. That's my maximum value of y. That's my minimum value of y. My y, we know the range of this function is y is smaller than 5/6, smaller or equal to 5/6, and greater or equal to 3/2. Oops, other way around. 5/6 is smaller than 3/2, which is this one, and greater or equal to 5/6. Now, could you have got this without drawing the whole graph? Yes, you could have. All you would have had to done is made it equal to k, and instead of solving b squared minus 4ac is equal to 0, solve b squared minus 4ac is greater or equal to 0. And that would have given you, so essentially what I'm talking about is you make it equal to k, so k will be equal to x squared plus x plus 4 over x squared plus 3. Make your quadratic, and then solve b squared minus 4ac is greater or equal to 0. And in this case, it would have given you, and that's a quadratic inequality you'll have to solve. It will be a quadratic in k, remember. You have to take it over, and then you have to, and that would have given you, and when you solve that quadratic inequality, you would have found k will be smaller or less than 5/6, and, well, greater or equal to 5/6, and lesser or equal to 3/2. But k is y. K is essentially your y, so that gives you the range. So you can find your range without drawing your actual graph. Right? So that's it for now. Try some of these questions yourself. If you have any questions, please ask me in lesson. That's it.